Okay, guys, here and elsewhere. So I'm quite excited about it. It's our inaugural ARIVE lecture on XR. My name is Holger Regenbrecht. I'm a professor here at the Information Science Department at the University of Otago in Dunedin, and I'm co-leading our Human-Computer Interaction Lab together with Tobias Langlotz. And so I'm also a little bit nervous because we haven't tried that before. We'll see how it goes. I left actually space on the slides on the left-hand side just to for the video images. So if you want to have your Zoom images, placed elsewhere, place them there, so then you see the rest of the slides. So the ARIVE consortium is actually a new thing. It's brand new, and we want to use somehow our joint expertise to teach ourselves about latest trends and advanced topics in virtual and augmented reality. And so I will go over today just an introduction. And the introduction is mainly about our consortium and our consortium partners. But I also will give a little bit of an introduction into why are we doing it? What is so important about XR or virtual and augmented reality? And then, of course, I give you a brief overview of what to expect in the next 12 weeks or 24 lectures given by us and others. So we have a mixed format here. So, for instance, here in our lab, as you perhaps can see on Tobias' stream, we have students from the University of Otago, which are co-present in one room. And I saw already that other partners are joining in via Zoom, which is great. And this will be the hybrid mixed model we will use for the next time. We will record all of those lectures, and we will upload the lectures, and I hope that it is recording, yes. And for some lectures, probably we won't see them live or in a hybrid format. It depends on the partners who are giving the lectures. They will pre-record them, and then we will just watch them at the given times. But I will come then to that in a second. If you have any questions, you can try to raise your hand somehow and try to ask the questions in between, or you save them for afterwards. That is applying to all the people in the room here or out there on Zoom. Okay, let's get started with the introductory lecture. So what is the potential for XR? And that's a little bit of a personal view on that topic area, and what are the challenges. But before we start to look into that, I want to go into the quick definition. So XR is probably, I would say, it might be the new abbreviation for the next hype to come. So a little bit like AI is at the moment. We called it in the past virtual and augmented reality, but it's actually quite more than that. It is anything the X can stand for before the reality. So it could be virtual realities, it could be augmented reality, it could be diminished reality, cinematic, extended, whatever it is. And so we call it XR as one placeholder definition. In the next lecture, which Alex Plopsky from our lab will give, he will bring more of those definitions and to be a little bit more precise what we are talking about here. But for now, let's talk as XR about extended reality or virtual reality and augmented reality. Okay, so. I think, and we think, actually, that the future of human information interfaces is actually quite bright. So it will be highly interactive. It will be real-time interactive. It is not that you wait for the result of your decision-making or whatever for seconds or hours or even longer. Everything is real-time interactive. So our whole information world is interactive. It will be three-dimensional. Three-dimensional can be either we have our 2D displays arranged in spatial arrangements in real or virtual environments, or it can be that we really use three-dimensionality for everything we do, interacting with, visualizing, and so on and so forth. I think XR will be transparent, so the human-computer interface, the actual computer interface will disappear. So we don't, it actually starts already now, right? That we don't know whether that there's always a computer in between us and the information, right? And it will be more and more so because we don't have to know whether there's a computer between us and what we want to achieve or no, right? So that transparency will hopefully eventually achieved, right? It will be engaging. So it's not only that we operate a human-computer interface. We engage with interfaces. We engage with our real environment. We engage with the virtual environment, and with all the mixed forms in between. And that environment will be information-rich, complex, dynamic, right? Instead of we are pressing one button and get one result, or we are crunching a bunch of numbers. We will have a dynamic, complex data and information environment we are engaged with. With smart, I mean, it is probably an adaptive environment. The environment knows about the users, the environment knows about our intentions, the environment knows about where we are and where we want to go. So it will be context sensitive, context adaptive, and will respond to our engagement with the information environment. Probably it will also be multisensory. So today, in all of our information displays are mainly visuals and sometimes also acoustic, but there are more senses than those two. So probably we will also speak to other senses. We will sense other things with our bodies and in our environment, but we will also stimulate other senses, let's say like smell and touch and force and so on and so forth, right? The new human information interfaces as implemented by XR will be ubiquitous. So they will be everywhere. They will be omnipresent. They will be pervasive. They are not bound to a desk and a computer screen and a keyboard, right? They will be everywhere and they will be intuitive to use. So we don't, hopefully for less complex everyday tasks, hopefully we don't have to learn how to operate a computing system. It will operate or interact with us, right? And this is, I think, in the end, and there are more, you can complete that list, and I'm pretty sure my colleagues out there could bring up at least the same number of additional characteristics of future XR environments. So I would think the future is probably exciting when we talk about those XR interfaces. So like me, others have worked in the field.
So Holger, this is Rob. I thought the X was actually, I thought it meant exciting. I think that's what
Cool.
Exciting reality means.
So perhaps we should, so Alex, perhaps you should take a note. We are talking about exciting reality. Thanks, Rob. Yeah. So why didn't that happen, in the 90s when we started, with, the first big hype of virtual reality, and later in the late 90s with augmented reality. So why now? Why not, 10 years ago, 15 years ago, 20 years ago? So I think there are many things which happened in between, but I will highlight some where I think this really was the game changer. So for starters, the display technology changed not that much in terms of the technological ingredients, but mainly in terms of affordability and presence in society and technology. So people like the people at Oculus did us really a service of bringing out, in that case, a head-mounted display, which was not costing $25,000 or $100,000, which normal, head-mount displays cost in the past, but now less than $1,000. So suddenly we can use it for professional activities, for leisure activities, for everything. And that's not only the Oculus Rift or the HTC Vive, but also developments like, with Lumos or Epson or Microsoft HoloLens and so on and so forth. So that is that made a big change in the success, or in the beginning success of XR, of exciting reality. The second big factor from a technology point of view is that we now have integrated development and design environments, which can be used also by non-experts to produce those experiences. So for instance, those engines like Unity or Unreal or WebXR, they allow us to produce real applications in a reasonable short period of time with a reasonable short period of training. So that wasn't always the case. In the past, you had to hire a bunch of computer scientists to build, an application for you, and otherwise you simply couldn't do it. That has dramatically changed. So that has changed the way we develop applications. In terms of what we can actually display, and virtual and augmented reality is very, at least, graphics hungry, right? It's greedy. So we need a lot of video and graphics processing power to do or to deliver the environments we want to deliver. So lots has changed. We have now GPUs everywhere. In almost all devices we have GPUs. In the bigger PCs we have, you know, almost thousands of potential virtual or real GPU nodes. But even on tablet computers and handheld computers and phones, we are now able to render virtual and augmented reality content. And that also made a big change to dedicated machines only running virtual reality applications in one room or one center, right? And finally, there are interaction devices which either come with the new head-mounted displays, for instance, you know, like the controllers, which are, you know, now precise and accurate and work quite well. So we can actually do things in the virtual and augmented environments intentionally, and it works, right? Or even, you know, things like, you know, the motion control, leap motion controllers or something like that, right? So we have those whole technological developments lead to now, I think, through a potential breakthrough in XR technologies in lots of sectors. And that's why I think it's also very timely that we do those lecture series now, and I will come to that. So let me share with you some of those initial ideas on how augmented reality and virtual reality is or will be used in the future in different sectors. And I just picked a couple of those. So you probably saw those interesting photographs, overlaid photographs accompanying the new Microsoft HoloLens version 2, or latest version actually. So one scenario, it's a very common scenario, and lots of sectors want to have that, is the on-site, just-in-time information on, let's say, instruction manuals or remote expert advice and so on and so forth. So we wanted to have it there intuitively at the right place at the right time, and without using any manuals or going to a website or something like that, right? So this is a very, very, very common scenario for XR. If you combine that now with the upcoming Internet of Things and the sensing technology, in particular with industrial IoT, then we have data streams coming to us humans, which are probably not comprehensible without XR technology. So it's just massive. So how do we process as humans and interact with that kind of information if we don't have those complex, rich, and embedded interfaces which XR provides for us? So this is one of the examples, and you see here, sitting on a tablet computer, and you can do augmented reality with IoT devices, and you get all the information, right? A rather recent example, and it's quite a humble example, is that Walmart example where they train their staff. In that case, I think, if I remember correctly, it was preparing them for the Black Friday rush into their stores. So in that particular case, they just used 360 video to do that. But that's a very the interesting aspect here is that a non-tech company like that retailer is using virtual reality for that particular purpose to train people for the things to come without the need to expose them to the real thing, right? So they can prepare this up. So, and that is one of the signs that if companies like Walmart take up that technology, that there is more to it than just a little bit of research here and there in our high-tech and highly trained students' labs, right? Another example is, of course, entertainment well-being. I picked just that one example because it's quite an interesting, neat example where these are children at a children's hospital, and they are immersed now into a scene where they see a remote penguin colony where, you know, a camera is placed, and they can look around and can interact somehow with each other and so on and so forth. So it has all those aspects in it, like, you know, an entertainment aspect and the well-being for the kids, but also that kind of aspect of telepresence, which can be implemented now with off-the-shelf, and this is off-the-shelf XR gear. All you need is, you know, the people who install it, implement it, and that's the new knowledge you need to make it happen, and not necessarily only the computer science knowledge to build systems. Therapy is actually one of the classic application examples for virtual reality, in particular for virtual reality. It has survived all the you know, deep valleys of disappointment with virtual reality. So since at least the 90s, there is a continuous commercial interest in providing therapeutic applications with virtual reality. Think of, you know, treating fear of heights with virtual environments, fear of spiders, or a very commercially valuable tool, fear of flying, if you want to train your employees in, you know, overcoming their fear of flying so that they can do their business for your business, right? So this is a very old application of virtual reality, and it's still growing towards new phobias, to fear of public speaking, and so on and so forth, right? So put on your headset and cope with it, and learn to cope with it by facing the simulated environment. And that shows also the power of virtual and augmented reality. It's so convincing that you can transfer what you learn in there to the real world, even if that that is a virtual environment and not an augmented environment. Second last example, and I'm convinced that this will be the next big thing. We will go away from probably two-dimensional video watching to interactive three-dimensional stepping into scenes, so mainly called volumetric video. So what you see here is a recording of an actor or person in such a studio, and then it will be stored and processed and provided as a volumetric video, so that you can put on your head-mount display and you walk into the scene and interact with those characters. And a similar technology can be used also for telepresence applications, where you try to capture on one side an environment and people in it and objects, and then you stream that to another side, and then you can interact in that kind of environment. So these were a couple of examples where we think the future might go to, and where others think that the future might go to. But what is needed to make that really happen? You know, those, you know, more high-end demanding application scenarios. And so there's a long list of things, especially what we have to do in research and in early development, right? So how do we deliver the high quality information display, right? How do we make, you know, the information display rich and convincing and high fidelity, or high fidelity enough for the given task, right? Huge challenges in it, and we have some of our partners in it which really specialize on that kind of aspect. If we mix virtual and real in some shape or form, so how do we make that blending between the virtual and the real coherent? So how do we, that has to do with where is the information located, how is it rendered, how is it lit, and so on. So how do we interact with the information presented, and so on and so forth. If we want to deliver convincing experiences, we have to understand human perception and cognition. So because only that, if we really understand that, we can address that with our interfaces, which are a new form of reality. So we have to probably, mainly as technologists, we have to know more about perception and cognition to deliver the right solutions, right? Post-Windows icons, menus, pointers are probably a thing of the past, even if we use them still also in our applications when we have to press a button on a tablet computer or something like that. But this will hopefully be gone in a couple of years' time, perhaps. Still accurate and precise localization and tracking. So lots of advantages have been built in the last couple of years and decades. So we have now super high precise and accurate tracking already with the, for instance, with the tracking systems which come with the head-mounted displays. But still, for certain applications, think surgery or brain surgery, you need better localization tracking. If we go outdoors, it's even more so if we want to augment faraway objects, precisely and accurately enough. So how do we track the user's position and orientation in space? So this is a technical challenge still out there, even if we have progressed a lot in the last couple of years. Data visualization and analytics, there's a certain trend here because of the immense richness of the data, and people talk about big data and the 4 V's and big data. So how do we interpret and interact with that kind of richness of data and complex data? And probably one answer is really to have it as immersive analytics. So we go into the next dimension and into real-time interaction with the data just to cope with that kind of complexity, right? Again, making the interfaces disappear. So how do we do that? How do we really sense things with humans, and how do we address the senses of the humans by stimulating them? How do we detect emotions? How do we influence emotions of users with our interfaces? It's a big topic, and you will see that when I come to our partners, that this is really a thread which goes through many of those partners' research. So it's really a hot topic, right? Bring back fun alongside the efficiency of the interfaces, right? When in the past we said, okay, yeah, people, systems have to work, they have to be usable and highly effective and efficient. Probably now is also the time to think about how do we bring in the fun aspects into our interfaces, even for serious applications. And here, the gamification aspect is massive here, right? So what can we not only learn from the gaming sector, from the computer gaming sector, in terms of engagement, but also what kinds of new forms of interaction are out there to gamify or to produce serious games or games with purpose, and so on and so forth, right? Okay, so interfaces will be more intelligent and autonomous. So it's not any longer click the button and something happens. So the environment will, respond to us and will do things in a more autonomous way. And last but not least, how do we actually enable presence and telepresence? So the sense of being there in the environment, either here or in a virtual environment or elsewhere, virtual or real, right? So this is a defining element of virtual reality, and I will give another lecture on that, and we'll go a little bit deeper into presence aspects. So in the end, it's the question, how do we deliver new and meaningful experiences with computer-mediated realities, which is exciting reality, right? So this is the big question. So now the ARIVE consortium comes into play. So this is ARIVE. So ARIVE is a group of groups. It's a network of groups in Australasia. That means in Australia and New Zealand for now. And we are all interested in those XR, exciting realities, interactive virtual environments. And the red dots here on the slide, point to the locations where we are. So from Brisbane to where are we? To Sydney, to Melbourne, Adelaide, Auckland, Christchurch, Wellington, and Dunedin. And actually, it's a fun. And wait, did I miss Canberra? Oh, Canberra, sorry about that. Canberra, yes. CSIRO Data 61 is probably in Canberra. So it is a very new consortium. So Mark Billinghurst, who works for the University of Auckland and the University of South Australia, and Bruce Thomas from the University of South Australia, they initiated that consortium, and we thank them for that. And so it is actually, there is a very high concentration of really highly skilled XR experts down here in Australasia. And so it really makes sense to combine that kind of knowledge and expertise into one network. And it is one of the largest AR/VR networks in the world. And perhaps academically, it might be even the largest. I'm not sure about that, but it's a very good and substantive group of people. So if you want to know anything about XR, so probably this is already the right group to work with. So it's really a good experts group, right? So what are the goals for ARIVE? So they were set out by mainly by Mark Billinghurst in consultation with the rest of us. So we want to deliver into teaching. This is what we do, for instance, with this lecture series, right? We want to train the next generation of XR designers, developers, decision makers, leaders, whatever that is. We want to share our resources amongst our partners, and I will show you some examples what others have and where we might tap into. We want to grow the research community around XR because we think it's the future, and we want to generate research outputs that might be in the form of publications or prototypes or industry relationships or commercialization or whatever. And we want to transfer technology to our partners. So that means internally, but also to commercialization partners. So within our ARIVE team, we have those core research themes, and these are also the core research areas of expertise. And it covers roughly everything you need. Oh, what is that? Zoom crashed. Oh, it's still my PowerPoint. Okay, it was my PowerPoint, just a sec. Shift. All right.
We can still see and hear you.
Okay, very good, thank you. Which slide was I at? About 20?
Yeah.
No. Oh. Oh yeah, here we are, thank you. So this is when you want, if you want to build XR application, this is roughly what you probably need these days in terms of expertise, right? So you need interaction techniques, you need simulation and visualization knowledge a lot. You have to know about immersive analytics, especially with IoT and big data, education and training. Empathic, it's a new term, empathic and assistive technologies. Computational cinematic media, so we'll come to that, especially when it comes to Wellington, immersive gaming, and presence and telepresence. These are the topics. So this is the consortium. So around from 4 partners here from Australia, plus 1 Crown Research Institute, and 4 university partners from New Zealand, and I will go through those ones now step by step. Yep. So this is probably the largest group in the network. University of South Australia in Adelaide. It is actually a multidisciplinary group made out of different disciplines within the University of South Australia and their partners, and they have 2 main labs. One is the Variable Computing Lab, mainly led by Bruce Thomas, and they focus on spatial and wearable augmented reality and on VR for immersive analytics and collaboration, right? And the second group is led by Mark, is the Empathic Computing Lab, and that's, it is actually how do we sense emotional states and other states of people and use them to collaborate and interact with remote people, right? So how do we create an understanding between dispersed people by using their the sensing technology and stimulation technology, right? So examples for that would be you share your heart rate, or you share your gaze, or you share your gestures over a distance and give that to other people, right? So in terms of equipment, the Adelaide is very well equipped in terms of XR equipment. So I pick out 2 things. So one is actually a big 100 square meters spatial AR space, and you can see that actually down there in the image with the car. So you have a projection system which produces spatial AR. So you have real objects and you project onto the real objects so that you get a mixed reality impression, which is called spatial AR. And the second one is the EEG VR lab. And so it uses EEG technology to sense and then to transmit emotional states or fatigue or whatever, right? So they have 2 example projects I picked out here. So one is empathy glasses. So these are glasses which have an integrated eye tracker, and then now you use that integrated eye tracker to transmit your gaze in a remote expert scenario as depicted in the first Microsoft HoloLens scenario, right? So the remote person is aware of your gaze, and with that one you increase the communication capabilities between the two, right? And the other one is tangible analytics. So instead of using, freehand interaction or mice or other input devices, so you use tangible props which you 3D printed beforehand for your interaction with, and in particular with analytics environments. So that's UniSA in Adelaide. So next one is Monash in Melbourne. So this is actually in terms of data visualization research groups, this is really one of the top 10 groups internationally. So they have a long history in data viz. So what they do is they explore new display and interaction technologies to enhance decision making. This is what you normally do with analytics. And they are also this is also the group which coined actually the term immersive analytics. So if we talk about immersive analytics, normally we think of Monash here. So they have two main groups. One is the data visualization group and the other one is the human-centered computing group, and they work together and they publish in really high-end venues like Kai and Viz and TVCG and WIST and so on and so forth. We have one short video clip, and I hope it will play properly from Monash.
Our research is an anticipation of a future where we have headset devices that allow us to understand systems that we have to live and work in.
I'm interested in exploring new interface designs for emerging technologies like augmented reality, where we can see information overlaid on the real world.
I seek to leverage information to better understand our buildings and our cities and our human behaviours.
What I'm really interested in is helping people engage more with their data. Reality can help them solve their problems.
With augmented reality, what we can do is take the maps outside, so we can walk on a street and visualize geospatial data, geographic data.
Working in the Immersive Analytics group at Monash is great because we have a number of world-leading researchers in the areas of visualization, constraint solving, and human-computer interaction.
Okay, yeah, nice short video clip. So because I asked the partners to, if they want to provide a 1-minute video clip, and they did. Thank you very much, Monash. Next group is University of New South Wales in Sydney. So they have the Expanded Perception Interaction Center, EP Center. So they do mainly visualization research in the 4 art, design, science, medicine, engineering. And they have an integrated research with the Crown Research Institute, with CSIRO, Data 61, and Tom is the leader, is the director here, and is one of the group leaders at CSIRO. In terms of technology, they have actually a very big cylindrical display, which they say it's the highest resolution cylinder display you can have. It has 120 million pixels in 3D. It's 6.5 meters wide, and it covers a 340 degrees viewing angle, which is quite it's not quite impressive. It's very impressive actually, and it's augmented with a 32-channel audio system. And then they also have a dome display, which is also about 6 meters in diameter, and that's a 4K full dome, which they use for their work with their different areas here. Right, so that is equipment which we normally would not have, for instance, here at Otago, because it's also very expensive and hard to maintain. Right, University of Queensland in Brisbane. So again, here we come to so they have 2 main research areas. So one is, again, so emotional and cognitive states. So how do we measure them? How do we manipulate them? How we transmit? How do we display? How do we interact with those ones? And the other one is and that's quite rare but very valuable here, is a qualitative research group. So they go out there and do a qualitative design-led approach on site. And normally in our discipline, we have mainly quantitative research. So this is a really good addition. Having said that, they also do combinations of those two, right? So example projects are, they call it cognitively adaptive VR. That means, for instance, how you are interface should change according to your cognitive state or workload, right? That's one. Quantifying presence. So how do we quantify whether we are part of a virtual environment or not? And so that is measured to date mainly by way of questionnaires, answering questionnaires, or by observation. But can that be quantified? That's one of the research questions there. And also real-time emotion sensing. So how can we detect emotions and emotional change in real time? So these are the main working areas of our Queensland partner. Auckland is so it's the Auckland Institute of Bioengineering, if that is the right word. I think it is. Has two main groups, and Mark, as you can see, is appearing here again. So there are two groups. So one is led by Suranga, and that's the Augmented Human Lab, and they try to extend, actually sensory extend our human bodies and augment them with technology for different applications. To make that a little bit more tangible, examples here would be, they have one interface prototype for blind users where they can point at objects and can ask questions about those objects, and they get that then acoustically. Or they have an interface for deaf people where they can feel music, or they have insole sensors in shoes where they can sense your balance and where you can improve with a certain interface your posture. So this is one group of the Augmented Human Group Lab, and the other one is the Empathic Computing Lab, and that's actually what Mark. This is how would you call it? Probably a sister group of the Adelaide group, and they do physiological sensors and EEG measures to recognize and share emotions and brain activity. And then they do computer vision approaches to share a person's surrounding real or mixed environment. And they do share gaze and gesture and things like that over that. So it's all about that. How do we share those emotions amongst ourselves or our users? And that's called, or I think Mark coined the term empathic computing for that. Okay, so we have one message. I hope that will play as well. So this is Mark Billinghurst.
Hello, I'm Mark Billinghurst, the director of the Empathic Computing Lab at the University of Auckland. In our lab, we look at how we can use AR and VR technologies to enhance face-to-face and remote collaboration, and especially combining them with physiological sensors so that we can share what we are seeing, what we're hearing, and what we're feeling with other people. In my lecture, I'm going to talk about how AR and VR technologies can be used for collaboration. And that's a really important topic because in these COVID days, we want to be able to collaborate with people remotely as if we're with them face to face. And with AR and VR, we can use spatial cues to help us be able to communicate in a very natural manner. So I'm looking forward to talking to you in a few lectures, and I hope you'll be able to enjoy the content I'm going to share.
It was very arty, that movie. Yes. Okay. Victoria University of Wellington, so TJ and Ken and James Foley as an advisor, they run a lab which sits in the city of Wellington, and actually one of our students will go there soon. And so their main focus is on computer graphics, VR, AR, of course, vision, and digital content, creation and interaction with digital content. And so so they try to push what is possible now in film and media towards more interactive media and high-end visualization, including photorealism, 360 capture and streaming, rendering, character animation, and so on and so forth. What did I wanted to say? Yeah, two main projects at the moment. They're aiming at one which they call augmented teleportation. So how do you are teleported into an real mixed virtual scene, and remote collaboration support with mixed reality in general. We do have the HIT lab at the University of Canterbury in Christchurch. This is actually the lab Mark Billinghurst founded or co-founded, I don't know, in the early 2000s. And it's now led by Rob Lindemann and his colleagues, Stefan, Andrew, and Heide. And so They have a long history in virtual and augmented reality research, also in human-robot interaction, remote collaboration, and applied immersive game design. They have two main groups. One is the multisensory mixed reality group, mainly interested in 3D UI, 3D user interfaces, multisensory feedback, and long-term immersion. That means not only for one experiment or short-term, use of virtual reality. So what would it mean if we want to use it for longer? And then those short occurrences. And the other one is the applied immersive game design group, and they try to apply and develop 4 immersive game concepts for entertainment, education, rehabilitation, and industrial applications. So I want to point out one thing, or they have a couple of specialized suites of equipment, and I want to point out one. That's a little dome display here, but that one is actually very interesting. That's the multisensory VR framework or something like that. So it's really, so in addition to visuals and sound, you get also other senses stimulated, like the sense of smell or rumble or things like that, right? So that's quite unique, at least here in our circles. So we have also 2 short videos. We'll see whether they're also that artistic or not.
Hello, my name is Rob Lindeman, and I'm a professor at the Human Interface Technology Lab, or the HIT Lab, New Zealand, at the University of Canterbury. And I'm really excited to be giving a lecture later on in the schedule around multisensory virtual reality. So we've been working on how to deliver things beyond visuals and audio for some time, including haptic feedback, smell feedback, and various other cool things. And in addition to just building the stuff, which is hard, we are working on assessing when it makes sense to use it and where it makes a difference. So in terms of realism and presence and co-presence. So anyway, I look forward to giving a lecture and having a lively conversation around that. So yeah, I look forward to seeing you. Bye.
Bye, Rob. And Stefan Lukosz also sent a short 1-minute video clip, and I'm playing that now here with his nice, colorful background.
Hello, my name is Stefan Lukosz. I'm a professor at the HIT Lab New Zealand here in Christchurch. The HIT Lab New Zealand is part of the University of Canterbury. And in the HIT Lab, we do a lot of research on immersive technologies completely along the mixed reality continuum. My personal research focuses a lot on using augmented reality in applied settings and in applied immersive games. I've done so in the health domain for treating Parkinson and Alzheimer patient, and I've worked with the Dutch police to improve their situational awareness. I've worked with several sport-related teams on using augmented reality for feedback. And in my lecture on August 13, I will just talk about my experiences in this research and about the human factors involved in the research and how you can evaluate them. Looking forward to meet you in August 13. Until then, have a good time. Bye.
Bye, Stefan. Very good. So last but not least, us here, University of Otago. So we have here actually two groups involved. So one is the Human-Computer Interaction Lab and Group, which we are located at the moment here in the HCI seminar room, and the Visual Computing Lab Group. So we focus on theory, prototypical development, and evaluation of XR interfaces, virtual and augmented reality. We focus on high quality outputs. That's because we are a smaller group, so we have to focus a little bit more on the quality and less on the quantity. So we have as topics, for instance, computational glasses, which is the next version of pervasive augmented reality glasses you might walk around with, which are context aware and sensitive. We have mobile and stationary mixed reality, presence and telepresence research going on in different application fields. We do neuroscience-based in interfaces, so we're also part of the New Zealand Brain Research National Center, National Research. We do embodied interaction, continuous augmentations, and so on and so forth. So the visual computing group, they are focusing on computer vision, but also on information visualization and computer graphics. And so examples would be AR for live sports spectators, which is led by Steffi, or visualization techniques for AR in a general field, but also 3D reconstruction, for instance, of cultural artifacts. And we have also projects together, lots of projects together, and supervised lots of students together. So I use 2 examples here. So one is the AR Spectator project. That means how do we augment information in a stadium environment, for instance, at sports events live for individual spectators. And the other one, also where Rob is part of it, is a digital Mirai project where we do mixed reality storytelling and telepresence with our Maori partners down in Bluff, a very exciting project. So we don't have any video clips of ourselves. Do you guys, do you want to say a word into the camera? No? Look, I've got that here. Steffi, do you want to? Then come around. Just. You're on TV now.
Hello, so I'm Stephanie. I'm from the Visual Computing Group in Otago, and as Holger was saying, I'm mostly interested in visualization and augmented reality, in particular for outdoor usage on a wide scale. And I'm very much looking forward to giving my lectures in the middle of August.
Yep. Thanks, Steffi. Any other requests? No. So you will see Tobias and Alex soon with their lectures, and then they can introduce themselves. So this is now the final part of it, the lecture series on XR. So that, as I said, that will be for 12 weeks, 2 lectures per week, always at the same time slots, Tuesdays and Thursdays, 3 to 4 New Zealand Standard Time, and we will put those ones onto website, the recordings, but also some of the lecture slides for the lecturers who want to publish the lecture slides can do so, and we will also put there the short description of the lecture series. Where you see all the dates in it, and we focus on 5 different areas. So one is displays, the other one telepresence, augmented experiences, rendering and visualization, and the whole thing is embedded actually in a lot of augmented reality and virtual reality applications. So this is the rough schedule for the lecture series. So as you can see, we have a mix of presenters here, and we focus on what they are really experts in, right? So what you here get is advanced topics in XR from the experts in the field. So it's actually quite a valuable lecture series. So we will have, after those introductions, my introduction and the recap of definitions and concepts by Alex Plopsky in 2 days' time. We will have, one group of presentations about displays. We are focusing on optical see-through head-mounted displays and computational glasses, and on immersive projection technologies. We will talk about presence and telepresence, and with stationary systems, but also with mobile and wearable systems. And there's an overlapping topic with augmented experiences, which is the University of Auckland's empathic computing between remote partners, which will be given by our Auckland partners. Then we have a whole block of augmented experiences, multisensory experiences, augmenting humans, as you saw from the previous slides. There might be some lectures might change a little bit here, but this is roughly what we are doing. And after our mid-semester break, we will return to rendering and visualization techniques given by different partners. As Steffi mentioned, she will be the first after the mid-semester break, I guess. Yes, you will be, and then followed by Monash and Victoria University presentations. And the final block is actually applications from Sydney, and again from us. And I will probably give the last lecture and talk about XR ethics and professionalism. That means, so are we actually, should we be influencing and be concerned about how our stuff is used, what we are developing as engineers, as technologists, as designers, as scientists, in terms of perception, ethical and legal aspects. And then we'll round it up with that one. So that was it. I was almost in time. Thank you very much. For those of you who have a little bit more time, you can ask some quick questions, and otherwise I would then stop here. Are there any questions? Get a little bit of applause here. Thank you. I'm looking into the camera.
I have a question.
No question? No questions? You've got a question? Good.
It's Rob.
Yeah, Rob.
Yeah, so one thing is how to stimulate discussion. So it would be really good if there was definitely time and encouragement for people to ask questions. I think it's pretty unique to have assembled such a crew of people willing to present. And I really hope that it really promotes a lot of discussion. So it would be great. I don't know how to promote that, but it would be really good if there was a way for us to definitely make time for discussion. And what's the best way to promote that?
Yep.
One quick comment. We have two computers here myself. What we have, so we have a couple of students here. You take this basically embedded as a normal course. So basically they listen to this lecture and they do a project work. We have some extra time reserved for that, but of course that is a different time slot that makes it hard. So this is mainly for our discussion, but it's a good point. Maybe we will discuss that. And the other thing is what you can of course always do as a presenter. You keep your presentation a bit shorter to give a bit more time. This is of course always an option.
But good point, Rob. Really, because it is a unique opportunity for the rest of us and for the students to really interact with the experts in the field, right?
Either you or Tobias has to mute.
Yeah. Sorry.
Oh yeah. Thanks, Rob. Yeah. So Gun.
So hi, my name is Gunli from UniSA. Thank you, Holger, for the great introduction of the series of lectures. I wonder if it would be helpful to have a kind of central repository or a kind of online forum that lecture materials could be shared, and also online discussion could be going on across all of the institutions. Probably.
Yeah, thanks, Gun. Yeah, noted. So we will definitely share the material. So, but we won't force the others to share all the material. If you want to, you share it. We will share ours in terms of the recordings anyway. So we will record all lectures and we will share the lecture notes. And whether we can have a discussion forum, I will discuss that with Tobias. Yeah, but that's a very good point. Thanks, Gun.
Which also means if you don't want to share your content, you better let us know.
Yes, exactly. Yep. Any more questions?
Oh, it's Mark here. I just had one comment. Maybe for the last lecture or one of the later lectures, it might be kind of interesting or fun to try and do a lecture in an online social VR environment, such as Mozilla, something like this. So, and certainly the lab that we have in Australia and here in New Zealand, a few head-mount displays, so we could get a bunch of people in online together in VR. And then of course with Mozilla Hubs, you can do it through the browser, so anybody can join. So I'm not sure if you sort of put something like that as well, doing one lecture or so, maybe the ethics one, because it's involves so many slides or something, that you could basically try a social VR experience, or the collaborative VR lecture that we've got in the series as well.
Yeah, actually it's quite cool because we know that all the partners have the gear, right? So we can actually do it. That's a good idea. I think we will test it here, how it works.
Yeah, we did this with the other course.
Yeah.
I mean, there's several options. Hubs is Altspace VR. In our lab here, we've developed a plugin for Zoom that lets you stream VR into Zoom, so you can have somebody doing VR. So there's a few options.
Cool. Yeah, cool. Thanks, Mark. Okay. Any more questions from within the room here? No? Okay, thanks a lot. Thanks a lot all for staying with me and not falling asleep. We will have in 2 days' time, we will have Alexander Plopsky's and my lecture on definitions and concepts. It's a little bit of a recap because the whole series is actually meant to be for people, for senior undergraduate students or postgrad students who already have a background a little bit in our field. So it's not that you will hear 15 lectures on the basics of tracking, but Alex will give a little bit of a recap so that we are all on the same page, and and from there we go. Anything I forgot, Tobias? No, very good. Thank you very much. Kia ora, and we see you in 2 days' time. Thanks.